Hey, and welcome back to 2D Tiger. I've actually decided that there's a bit more interesting stuff going on now, so I'm not going to do a 1 minute short and just tease you about this. I've got a lot of the parts for the EDM machine here now. I got the 5mm bolts. These were an interesting one. I wanted to get ones with a straight shank, because then the O-ring will seal better on them for this base plate. So what I'm going to be showing you today is how I drill the base plate without cracking the plastic container. If you can see that bolt there, it's got about a 10mm straight shank section on there, so that'll be good for going through the center of an O-ring. And then those O-rings will actually, which I've got here somewhere too. Ah yes, here we go. Got a box of O-rings, just the right size, 5mm by 2. They're going to go in here in that little groove that's in there, and they'll go underneath the they won't go underneath, the bolt will go through that way, the groove will go in there, and they'll seal against the plastic and against the shaft, so the dielectric, the kerosene or the water, whichever I use in here, isn't going to leak out, hopefully. Now that's going to need me to drill a hole, or 6 holes in this case, maybe more, in the bottom of this. And drilling hole, if anybody has ever tried, you always run the risk of, with a twist drill, that it's going to just grab and split. Now I recommend, if you're going to drill these, get either a straight shank, a straight shaft, a straight flute drill, which are really hard to get, or get one of these step drills, because they're practically a straight flute at the cutting edge, so they won't grab and pull in. Unfortunately, I've only got a even one, so it's 4, 6, 8, 12mm. I want 5mm holes, so I'm going to use a normal twist drill very carefully. Let's see if we don't break it. I'm going to use my 3D print that is going to have the screws going through it as the guide. And in order that we don't split it, what you need to do is give it some structural support on this side, so that you can push against that, and then when the drill starts to bite through, it'll actually keep drilling without grabbing, because it'll have something to push against. It won't just go into free air and zip through. So what I'm doing here, I've got a bit of 70 by 35mm pine from the shed framing job. So it's just an offcut I've got here. And what I'm going to do is push this down against that. I'm not going to clamp it. I don't think I need to clamp it. I probably could if I wanted to. I could definitely hold it here and clamp it underneath. Actually, just for completeness, to show you guys, in case you're wondering what exactly you would do there, I think with this clamp we should be able to get underneath and get it nicely. There we go. So I'm checking that everything's in position. Actually, that works really well. So that's clamped together now. I've got that fitting in its correct position. The timber is solid underneath. I haven't jammed it down too hard, just need to hold it together. And let's see if I destroy something. I should be able to just go in. I'm holding it nice and square, making sure that the drill's not touching much of the sides of my 3D print. So there was a little bit of movement as it penetrated, but that did exactly what I wanted. It didn't go zoop all the way through in a hurry, so it didn't split anything. It shouldn't have propagated any cracks, and let's have a look at what that looks like. So there you go. Right there is one very neat and clean hole. I'm really happy with how that worked, so I'm going to do that for the other 6. And then we should be able to, there's a little bit of a burr on the inside, but we'll clean that up afterwards. What I'll do there is probably just by hand get the step drill and give it a little bit of a twist like that. And makes it worse. Nah, there we go. That's taken the burrs off. So yeah, I'm going to do the rest like that. You just got to do it slowly and patiently. You don't rush this, because you will break something if you rush it. Also, I recommend try and not have it go on the same hole as you had before, because then there's nothing behind the drill when it goes through. This is also really good when drilling delicate bits of timber and stuff, if you don't want them to splinter underneath, if you clamp them against another piece of timber, MDF is really good because it's fairly medium density by the name, and it's neutral, so it's not like it's got a grain or anything. So check that we're lined up nicely, fitting in our base of the Tupperware container, and we'll go again. And that's all it takes. Now, I've got provision for 6 holes on here. I'm not sure, based on how strong that 3D print turned out with the glass reinforced nylon, I'm really happy with the Polymaker stuff. I don't think that I'm going to do all 6 holes. We'll keep those as a backup. Because remember, this isn't like machining on a mill where you need to keep everything and stop it from vibrating. It's a very gentle movement. It only just kisses the metal that you're working away, that you're spark eroding. So it shouldn't need to hold a lot of forces. We just need to keep it in exactly the same place. I'm hoping that the thermal expansion won't be significant, that the fluid, the dielectric that I use, will keep everything at a relatively constant temperature, and things won't expand and move that way. So this is the 4th one. I think for now I'll stick with 4. So I'm actually using the drill on a low RPM as well, just to make sure everything's just going gently and slowly. Put that back there. Put my clamp away. I'm going to try and remember to put my tools away so the place doesn't get too cluttered. There, we've got 6 holes drilled, which is awesome. They turn out very clean. In fact, the first one that I tried to deburr is probably the messiest of them all. So I'll just, excuse me while I put that drill away. Now I'm going to have a go at how we go with these screws and O-rings. So I'm using, this is a generic nitrile O-ring kit. It's got 5 by 2mm, and I think they're just the right size for this. I might consider the 4, and I've also got to get the screw the right length. I might need to cut these screws off actually, either that or do a spacer underneath, because I wanted a nice long straight shank on there. Just check. Yeah, the 4.5s I think are the way to go. They hold onto the shaft nicely. So only going to do the 4 for now. That goes in there. And I don't know if you can see that there, that's maybe not in focus right there. Try and keep everything in the same field, but the O-ring sits nicely in that little groove. I'll do that to the 4 locations that I'm going to use. And hopefully that'll stop us from having any leaks. Hate to come out here the next day and find that the whole project is buggered because the dielectric leaked out. I think I'm going to use this tank as the main reservoir for the dielectric as well, and I've got a fuel filter, a cheap diesel fuel filter, and a pump that should circulate and keep the dielectric nice and clean, hopefully. Because everything I've read, the 2 things that are important are short pulse duration and clean dielectric. There's a lot of tricks with retracting the tool and stuff to get a really nice finish, but I am looking forward to the surface finish that it generates, because I remember back in my day when I was doing some plastic tooling design, we used to always specify to the manufacturer that we wanted a heavy EDM finish, because on the injection molding that came out with a really nice texture. There were some etched textures that they could do as well, which gave it grains that looked like leather as well, which is what they used to do on dashboards. But I like the texture of the EDM finish on the metal, and it's almost like a sandblasted finish. The sandblasting these days is easier, especially if you've been CNC milling something. Get rid of all those tool marks, just sandblast. Now, aluminium sandblasted and then gloss anodized gives a really beautiful texture finish too. I usually get most of my prototype stuff done that way. It makes for a really nice look. It's the easiest way of hiding the tool marks, the sandblasting, because people get carried away with sandpaper and filing, and that never I always looks like it's sort of like handmade afterwards. I like the squareness of CNC machining, so the least you can damage that, the better. So that's why a light sandblast works really well. So a little bit of a spacing issue on this last one. The other two went in nicely, but that then goes onto here. Nice. Not sure. Just got this one. I think that was the first one I drilled. For some reason, is not quite. Well, looking in this end, it looks like it's okay. You know, I reckon that one's just a smidge out by about 1 millimeter. I'm going to give that one a re-drill. It shouldn't affect the sealing. It might damage the O-ring in there. Just tidy it up a bit. So, you'll see me swearing in a few weeks when I say that. One O-ring's leaking. Oh no, it was good, it came out. Okay, so I haven't damaged the O-ring. I'll just remove this and try again. I may have also... Look, if I was hand drilling this, I might say that the base plate, that it's got an asymmetry to it. But 3D printing, I don't believe that. Now I've dropped the O-ring. One more. Find that other one later. Ah, here it is. Didn't go too far. So put that one back in. Yeah, you often get that. If one side's 0.5 millimeter out, then by the time you rotate it, it seems to always double that error. So you're hand making things. That's what I love about CNC machining. I don't think there's anything these days, well, this at the moment, I was going to say, metal wise, things that I'm making, usually I put them in the NC mill and drill the holes, because they're such a clean drill when it's set to pec, and the accuracy, that the cut, the side, it's all, the mill just gives such a good hole compared to the cheap drill press. It's really a nice finish. Certainly that kind of technology has come a long way. There we go. So that's the base solid, and that will now screw down onto one of these guys. It's a little bit long, so we're going to have to cut those. You can see that those bolts are a little bit long, but I knew that would happen. Because those bolts, they're sold with 25 millimeters of thread, and if you want a longer straight shank, you've got to get a longer bolt and cut them off. So that'll be the next bit. I'll just cut those off one by one. That's just being pressed in there with friction holding it. That's really solid. I might consider printing a spacer on there, actually, save me having to cut them off for now. And then I'll be on the next video, then I'll actually be cutting the aluminium railing and starting to put it all together. The only thing I have still to do is 3D print a mount for the motor. So hope you enjoyed that. Thanks for watching.